Okay, guten Morgen, everyone, and thank you for being here. So, I love Flutter for a lot of reasons, and one of them is the ability to easily manipulate pixels on the screen. I mean, to me, it was the first multi-platform framework where I could finally say yes to pretty much anything to my designers. This is a framework where designers can really express themselves. And let's see together how to improve your Flutter painting skills. But first, let me introduce myself. I'm Romain Rastel, and as you may guess from my accent, I'm a French software engineer. I'm working at Delin for the moment. Yeah, I have 13 years of experience in that domain. And my love story with Flutter started at the end of 2017, so it's something like 7 years ago now. I have created a lot of packages, Flutter packages, maybe too much, and I've been trying to maintain them since then. I also wrote some articles, Flutter and Dart articles, and I spoke in developer conferences like this one. So, like I said, I'm working at Delin. We are creating a gamified payment system where users can earn cashback when they pay in local businesses. For the moment, we are currently available in the north of France, but we want to expand in other regions, still France for the moment, and pretty soon in the south of France. So, I said that one of the main reasons I love Flutter is the ability to manipulate pixels on the screen. And we have at least 2 entry points in Flutter for that. At the widget level, we have the custom paint widget. And I'm pretty sure that a lot of you already use this widget. In fact, raise your hand if you used custom paint before. So yeah, pretty much everyone here, so good. So that's it at the widget level, but we can also paint at the screen at the rendering level through render objects. So I won't go through the details of render objects here. This is not the topic of today, but if you want to know more about them, I gave a talk last year right here in this very room. So if you want to, you can check it in the Fluttercon website. And yeah. So, what do we need to paint the screens in Flutter? First, we need something like a canvas in the real life. Well, in Flutter, we have something for that, and it's also called canvas. We also need tools, brushes, colors. This is the role of a paint class. And the last thing we need is primitives to tell what to do if you want to draw a circle, a rectangle, a line, or just paint individual pixels on the screen. And the canvas class has a method for that. So today, I will show you some tips to enhance your floating painting skills using a custom paint widget. And let me introduce you a big friend of mine, Happy Sparkle. So say hello to him. This is my real painting skills, so don't laugh about me, please. It is amazed by all the talks we have here at Fluttercon, so this is why there is a lot of speakers behind it. So today we will dive on some part of this code, and I hope you will learn something. But let's see what we can see here. So this is just a face with a mouth, and above it, 2 eyes. There is some sparkles around it, and they are rotating. I don't know if you can see, but the Happy Sparkles is a little opacified. We can see the speakers behind it, and the speakers are also moving. And it has some kind of magic. If I find my mouse, yeah, you can see that. Yeah, you can see that the eyes are following my mouse pointer, and he left some dust of fairy dust after my mouse, some particles here. That's the power of Happy Sparkle. So let's see how to create that. So first, the face. It's pretty easy. We just draw a circle using the draw circle method on line 12. We provide a center, a radius, and a paint. Which can be interesting here is that we want to have a gradient, and to do that, we use the shader property of the paint, and we provide here a gradient radial. We apply it as a shader. But we can also use a sort of shader. We can use an image shader or even a fragment shader. And if you want to know more about fragment shader, Henan and Raif made great talks about them. And in fact, in 2 hours in this very room, Raif will be speaking about fragment shaders. So if you want to know more about them, you know where to be in 2 hours. Now, let's see about the mouth. Very easy things for the mouth. We just create a rounded rectangle using the draw rect with 2R as a line 18. What can be interesting here is that we use different corners from the top and the bottom. Now, for the eyes. Really easy stuff also. We just want to draw 2 circles, one a white one and above it a black one. There was a lot of math here just to follow the mouse position, so don't bother to really look at it. But what I really want to show you here is the ability to repaint your painter when its properties changes. So here, I provide a mouse position to my pointer, and when Flutter sees that the custom painter instance is different than the old one, it will call the should repaint method here. And it will call it with the new instance, and it will provide the old instance to that method. And if you return true, Flutter will automatically paint, recall the paint method of the canvas. So here, when my mouse position is different, well, I return true, and that's how we can repaint only when we want your custom painter. So, now, let's how to put sparkles into your lives. The sparkles are pretty interesting because, as you see, they are positioned in a circle, and every sparkle is of a different angle than the previous one. There are multiple ways to do it. The hard one with cosinus, sinus, matrix multiplication. A lot of math, too much for me. And the second one, using clever or maybe a lazy way to do it with the canvas.save method. Raise your hand if you ever used the save method again, already before. Yeah, not a lot of people, so I think those who don't use it, you will learn something. So let's look at the Flutter documentation first. So it says that it saves a copy of the current transform and clip on the save stack, and then call Raster to pop the save stack. Well. When I first read this documentation, I didn't really understand what it was supposed to do. Let's see an example of what's going on here. Now, I will show you an animation representing what happened behind the scene when we call the save method on the canvas for creating our sparkles we saw before. So first, we translate the canvas so that the origin will be the center of the author circle. Then we draw a sparkle at a specified offset. Then we rotate the canvas. After that, we draw another sparkle at the same offset as before. And then we rotate the canvas again, and we iterate until we reach the end of our sparkles. And after that, we just have to call the restore method so that it will go to the place it was before. Oh, one thing to remember about this API is this quote for beloved Flutter Yoda. Always two they are, no more, no less. A save and a restore method. So that means that you have to call the restore method when you call a save, because otherwise you will have all kinds of problems. An exception, maybe, or I'm pretty sure of it. Let's dive into the code for that. So the first part is not very interesting, except at the line 6, if you want to know how to make add a blur to our sparkles. So at the line 6, we use mask filter to make the blur. And let's see to the code from the line 10 to the line 17. So first we call save on the canvas. Then, as we saw, we call the translate method to translate our canvas so that the center of the circle will be at the origin at 0, 0. The line 12 is, don't bother about it, it's just for the animation, for the animating rotation. It's not for displaying this thing. So forget about it for the moment. But from the line 13 to the line 16, we do what we saw in the animation before. So we draw a sparkle at a specified offset, which is sparkle center here. Then we rotate the canvas. We draw the sparkle again and again at the same offset. And we rotate it again and again and again. And yeah, we iterate until we reach the number of sparkles we want to draw. And then at the very end, we call the restore method on the canvas. So as you can see here, there is no sinus, no cosinus, even no matrix multiplication, no math here, or maybe just simple math. Division is okay. So it's really about, because when I read a lot of math, sinus, etc., I don't really know what it is supposing to do. And here, when I read this code, it's clearer for me. So I think it's the tip that you can apply in a lot of things. We can skew, we can also scale, we can do a lot of things with the save and the other method on the canvas. Another interesting thing here I want to show you, it's how to animate your custom painter with an animation. So here, I just provide an animation to the repaint parameter of the custom painter constructor. And in fact, you can pass any listenable object to it. So Flutter will attach to it, and every time the listenable notify its listeners, Flutter will call the paint method again. So that's how we can have this kind of animation using a custom painter. Now, let's see how to create our speakers here. So there are multiple ways to do that. If every speaker is in its own file, so if you have, I have 21 speakers here, so if I have 21 image file, I can use a draw image to do that. But if you have one big file, like a sprite sheet, like in video games, in fact, where all the speakers are in the same file, then you can use the draw image rect to only draw a part of that image. But, well, this is not very efficient because you have to call this method for every speaker here. If you have a lot of speakers, like in Fluttercon, well, it can be not very efficient. And if you want to draw this in a single call to the GPU, so you will be sent the image only once, and you will provide the positions of what we want only once, then you will have to call draw atlas. And for that, you just have to provide the sprite sheet, the positions of the part of the sprite sheet you want to draw, and then where you want to draw them on the screen. And if you want to have the best performances as possible, there is a draw row atlas method. So it has the same semantics as the draw atlas, but instead of providing a list of rectangles for the positions, you have to provide bytes row list. So it's maybe harder, but this is really useful if you want to have the best performances as possible. So here, in my code, I only use draw atlas. So let's look a little at the code here. So as you can see, we only use the draw atlas method at line 24. So it's only one time. So what we do here is that we provide a sprite sheet. So my sprite sheet here is just a long line of 21 speakers. Each speaker is about 400 by 400 pixels, and they all have the same offset for the top. So it's easier to get the speaker we want. Then we need to provide to the draw atlas method a list of rectangles which represent the positions of the speakers in the sprite sheets. For example, if we want the speaker number 9, which is Mangides Kasloskas here, who, by the way, created Flutter deck, which I use here to create this presentation, so thank you. If we want to get this man, we have to provide a rectangle where it's left, it's our 400, which is the width of one speaker. We multiply it by its number, so here it's 9, and then we get the left position. The top, as I said before, is 0 because we just have one line. And then we provide a width and a height of 400 because all my speakers have the same size. Then we need to tell Flutter where we want to put them on the screens. So we have to use a list of RR transforms objects. An RR transform object, it just carry the position. So it will be at translate X and translate Y. We can see that at line 19 and 20. Don't care about our compute the offset here because it's too much math behind the scene and it's too early for that. So just get that we have the offset and then we provide the X and the Y position to the translate X and translate Y. And then we can provide the scale at line 16 to tell what is the size we want in the screen. So here, if I want Mangedas to be 800 pixels by 800 pixels, I just have to provide a scale of 2. And then if I want it to be at the top left corner of my screen, I provide 0, 0 to translate X and translate Y. Then we can also provide a paint, and my paint is at line 4 here. We can see that I added a little opacity to each speakers of 0.8, so that's how you can have all your images share the same either color of opacity. But if you want to have different colors for each part of the sprite sheet, you can. You just have to provide, I don't remember which null is that, but you can provide a list of colors. And the list has to have the same size as the rects and the transforms list. You can also provide a blend mode if you want, and also a rectangle for a cull rect, and this is only used for optimization, I think. Another interesting particularity of my body here is how its face is a little transparent. Because we draw every shape one after the other, there will be like, so we draw the face, then we do the mouth, and then the eyes. So each one is above the other one. And let's see what happens if we set the opacity on each color, on each paint of each shape. So if I decrease my opacity here, I hope that you can see that there is a little yellow in the white of the eyes. And this is really not what I want. What I want is that. No yellow in the eyes. How can we do that in Flutter? Well, there is a method for that. And that method, it's called save layer. Raise your hand if you ever used save layer before. Oh, okay, yeah. So, if we activate it, as you can see, no more yellow in the eye, and it's pretty interesting. Let's see a little about this in the code. So what is interesting here, it's from line 10 to 17. First, we call the save layer method. We provide a rectangle where we want everything after to be combined. Then we can provide a paint. And here, in the paint, I provide the opacity I want for the whole thing. Then, between the save layer and the restore, you can call a lot of things on the canvas. And in fact, save layer will combine everything as it were one drawing only, one layer if you want. And that's how you can do something like that. Once again, let's look at the Flutter documentation to understand what's the goal of this method. Well, don't bother to read it. This is exactly what happened when I first read the save layer method documentation. I always need examples to really grasp the concepts, and that's what we will do next. So here, we have a simplified example with overlapping colors. We have the same squares at the left and at the right, but at the left, we set the opacity on the color, on the paint of each shape, and on the right, we only use save layer, and we set a solid color to each shape. So if we decrease the opacity here, I think it will be more interesting for you. Yeah. So as you can see here, I hope, yeah, there is a bunch of mixing colors here, 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 and not here. So when you have this kind of problem, well, remember that save layer can save your life. Let's look a little at the code here. So as we can see at line 11, we set the opacity on the left. We set the opacity to the color of the paint for each rectangle we draw. So this is without save layer. And on the right, at line 16, we provide a solid color. And for the opacity, we set it on line 4 when we provide it to the save layer method. And that's it. We call restore at the end, and that's how we can overcome this issue. But yeah, there is a but. We need to be careful with this power. I won't go into details here, but the Flutter documentation says that generally speaking, save layer is relatively expensive. If you want to know more about that, there is a little paragraph in the Flutter documentation to explain to those who understand what is going on the GPU, so that you will understand it. So what you have to remember here is that it's not a cheap operation. For example, if you can to make another, you also say that. Well, there is maybe sometimes there is a bit, or not that, there is a better solution. For example, here, if I want, I will try something. So to note that, toggle marker, yeah. So if here, I don't want to use save layer, instead of rectangles, I could create, so yeah, I had to improve my drawing skills, I know, don't laugh. So you can only draw, this is a disaster, only draw shapes like, roughly shapes like that, okay, and you won't have shapes overlapping each other. So by this way, you don't have to use save layer, but sometimes you have to, and it's okay to use save layer. But if you need to be performant, well, you can try to do things with another way. Now, let's see how to create some particles here. Yeah. So my particles here are just rectangles of different sizes, of different opacities. So we can just call draw rectangle for that. But if we have a lot of particles, well, yeah, you can see that there is a lot of junk here, and it cannot keep up. Too much particles, too much things for Flutter here. So there is a better way to make it efficient. This is the draw vertices method. So once again, draw your hands if you use draw vertices before. Some people, okay, well, great. So I won't go to all the details of draw vertices here. I just want you to know when it's good to use it. In fact, Philip Rashek made a really great video about draw vertices, and if you want to know more about them, I highly recommend you to watch it on YouTube after it. So with draw vertices, yeah, I didn't remember if I did it, but yeah, we can see that it's really smooth. So let's look at the code when we use draw vertices. So as you can see, I don't call it for every particles. I only call it one time. We provide vertices, we provide a blend mode, and a paint. So the vertices instance represents all the points I want to draw I want to draw. And then we will need to provide how we want to link each position. So here, what I want to do is rectangles. So I have to create 2 triangles for that. And to do that, we need to, because I want rectangles to be positioned at different thing. I want individual rectangles. In fact, I don't want 2 rectangles to be linked each other. So we have to use a vertex mode dot triangles. When we use that mode, Flutter will tell to the GPU to draw for every 3 positions, it will draw a triangle. So yeah, let's see how to do that. Yeah, if I want to draw this triangle, I will just need to provide A, B, C. But if I want to draw a rectangle like this one, I have to provide 6 positions, A, B, C, and then D, E, F, because he only knows how to create a triangle with 3 by 3. But as you can see, I need to provide 2 times 2 points. The points A and E are the same, and the points C and F are also the same. So if you have a lot of points to draw, sometimes it's better to do otherwise. So here, if I only provide the positions 2 times, or not 2 times, but if A and E, if I provide A and E and also C and F, I have to provide 6 positions. But we can also provide only 4 positions and then provide a list of indices that will represent the position we want to draw. So that's what I do in line 17. I provide a list of indices. So here, when we do that, the first triangle will be the points in indices 0, 1, and 2. And then the other one will be the points at indices 3, 0, and 2. And, well, here we don't need to provide 2 times some positions. So it will be memory-wise more performant if you have a lot of positions to draw. So now, let's do a quick recap of what we saw here. So first, we saw how to draw simple shapes on the canvas. Then we saw how to repaint the canvas when your widget rebuilds. After that, we saw how to not be bored too early by saving you for doing too much math. We also saw how to repaint your painter automatically with an animation. Then, with Draw Atlas, you learned how to make a single call to the GPU and draw multiple images on the screen at the same time. And I hope I demystified the save layer method for you by providing you one use case when it can be very useful. And in fact, it can also be useful with some clipping. But I didn't want to go to the details because it's, I think, really hard it was really hard for me to make it understandable, sorry. But sometimes if you have an image and if you have a background of a different color from the image, you can see a border from the background which is around your image if you're clipping your image. And with save layer, you can overcome that issue. And finally, we saw how to draw efficiently a lot of vertices on the screen. So it is all for today. I hope you enjoyed the talk and you learned something. If you want to give me some feedback for me to improve myself, you can scan this QR code here. If you want to contact me on Twitter or X, if you want, this is my handle. And if you have any question, and I think if you have time, 9 minutes, I think, I will be pleased to answer them, or to try to answer them. So, thank you.